Okay, so here are those other three examples that I said you might want to look at. So look at number one. What's the first thing we do? Remember, they ask us to factor, so what's the first thing you're going to decide? How many terms you have, great. So plus sign right in the middle of everything, multiplication to the left of it, multiplication to the right of it. You've got two terms here. Excellent. Anything in common? Good. The x squared minus 4 is in common, that parenthesis, so I'm going to factor it out. And when I factor it out, yes, you write x squared minus 4, and out of the first term, 2x remains, and then I have the plus sign, and the 5 remains. Excellent. Good. So we do have a multiplication problem, right? Because I mentioned factoring always ends in multiplication since you divided. Done? Some of you say yes, some of you are like, yeah, that x squared. You're right. That x squared is a really good tip that parenthesis of x squared minus 4 might still factor. So, time to do some side work. Now, remember what I mentioned before. When we first learned to factor, we learned to factor trinomials. So, we have an x squared and we have a minus 4. Technically, descending order means there's an x in the middle, right? Do you see any x's in the middle? Neither do I, so technically that's 0x. Cool? Okay, so remember the process. Take the first term, or pardon me, the first coefficient, multiply by the last. What do we get? Negative 4. So tell me all the combinations that multiply to negative 4. 1 times negative 4, negative 1 times positive 4, 2 times negative 2. Doesn't make sense to write negative 2 times 2. It's the same, yes? Okay. Check them out. 1 times 1 plus negative 4. Does that give me a 0? Nope. Negative 1 plus 4. Does that give me a 0? Nope. 2 plus negative 2. Does that give me a 0? Nope. That means this will still factor, which means I am going to replace. I am going to take out the 0x, and I am now going to write x squared plus 2x minus 2x minus 4. And now we're going to group. And we've grouped before, so let's walk ourselves through this to make sure we're good. Out of the first grouping, take out an x. Out of the second grouping, since the first term is negative, you know you're taking out a negative. And it looks like there's a 2 in common. So out of the first group, when you take out an x, what remains? X plus 2, good. Out of the second group, you took out a negative 2, what remains? Good. Negative divided by negative is positive. And that's positive also. Ah, this problem looks familiar, doesn't it? So we factor out an x plus 2, and you're left with an x minus 2, aren't you? So this answer keeps factoring. And the final factoring ends up to be the parentheses of x plus 2 times the parentheses of x minus 2 times the 2x plus 5. Here is the factored completely format of problem number 1. Cool? Excellent. Okay, just making sure you're good with it. Yes? Let's look at problem number 2. How many terms? Good, 2 terms. Plus sign in the middle. This is a multiplication problem to the left. That's a multiplication problem to the right. Excellent, you're getting the hang of this. Anything in common? Yes, the parentheses of z squared minus 9. Okay. Z squared minus 9. Okay. So what are you factoring out? You're factoring out z squared minus 9. Okay. You're like, it's obvious. I know, just thought I'd ask. So our first term, those cancel. You're left with 4z plus The second term, these canceled. You're left with a 3. Wonderful. Are we done factoring? It's multiplication. You're like, wait, that z squared minus 9 looks familiar. Better look familiar, because even though the variable's different, it kind of looks like x squared minus 4. There's 2 terms, and here's the great thing. They're both squared, or they're both perfect squares, aren't they? So if I take a look at z squared minus 9 over here, and I write it with 3 terms, because z squared to the first, no z's, right? And I take the first coefficient and multiply by the second, or the last coefficient, you get negative 9. I need a 0 in the middle. Yep, 3 times negative 3. Seems like a little bit of a pattern, doesn't it? Make the replacement. Instead of a 0, you have a plus 3z. Whoops. And you have a minus 3z, minus 9. Looking familiar. You get to group it. A z out of the first pair, right? Negative 3 out of the second pair, yes. Okay, so when you take the z out of the first pair, z plus 3. Take a negative 3 out of the second pair, z plus 3. Whoops, ran into my board. So you have z plus 3, because that's what's in common, and what's left with z minus 3. Looks familiar, doesn't it? So, your final factored format on number 2 is the parentheses of z plus 3 times the parentheses of z minus 3 times, 4z plus 3 in parentheses. Good? Yeah, the z squared minus 9 was basically the same problem as x squared minus 4, because they basically came out the same. You're like, it's a pattern. You're right, it's a pattern. But more on that later in another video. Let's look at number 3. Okay, that's long. How many terms? Excellent. There is a multiplication problem and then an addition sign. And that's a multiplication problem and then an addition sign. And there's a multiplication problem. 3 terms. Anything in common? Yes, the parenthesis of 4x plus 1. So I'm going to factor out the 4x plus 1. How you guys doing? Is this making sense? Good. So when I write 4x plus 1, what I'm factoring out, let's see what's left. Cancels out of the first term. What remains? X squared. There's my plus sign. Second term, that cancels. What's left? 2x. Third term, those cancel. Plus 5. Yay! Are we done? You're like, there's an x squared. You're right, there's an x squared. It's multiplication, but that x squared means I might be able to go further. Okay, here's the deal. I went through these on both of these problems 1 and 2, made sure we had 3 terms, and worked out the process of finding the combination, because this is 3 terms. And I need to know the process. In terms of factoring a trinomial, I take the first coefficient and I multiply by the last coefficient. And now I need to find all the combinations that multiply, in this case, to a positive 5. Well, that's a positive 1 times a positive 5, or a negative 1 times a negative 5. Okay. And then I need to check them. 1 plus 5, is that 2? Nope. Negative 1 plus negative 5, is that 2? Nope. So does this trinomial factor any further? No. So your final factored format is the 4x plus 1 in parentheses, and in parentheses, x squared plus 2x plus 5. Good? Are you glad you tuned into this? So am I. Have fun, guys. I'll catch you on the flip side.